Tom's not the only person watching it, so. Yeah.
It's Tom. Oh, I watched a 2.9 version of it.
Good.
I heard it was a recording, and you're like, guys, we're recording this now. Like, that is so stupid.
Now you're on the next one. All right, here we go. Taryn, can you close that door for me? Here we go. So this is the last section for this. Now, what we are looking at here are some, I guess they're shortcuts sometimes. So expanding and factorizing special products. So these are particular things that always behave, particular expressions or factors, that kind of thing, that always behave the same way. And there are some particular things that we can look out for, and if they fit a certain template, then we can use a shortcut and just kind of get the whole thing to get it away. Square of a difference now, I'm pretty sure. Okay, so this part here, so perfect squares are expressions that are the same thing squared, obviously. So something like, if I have 2 plus x, or sorry, I won't do it that way, x plus 2, you're right, Lachlan? Squared, it's fine now, yeah, that'll be fine. X plus 2 squared, then this is the same thing squared. Now, if I expanded that out, that would look like x squared plus 4x plus 4, and that's a quadratic trinomial, that's a perfect square. Perfect square because half of the middle term is the end term squared. So there's another one. Can anyone think of another one that could work? It's a bit of an ask off the top of your head. Taryn? Correct. Oops, 10x plus 25. Why is that perfect square? Well, because the last term is half of the middle term squared. So that, if I factorize that, that would look like x plus 5 squared. And it's a perfect square because it factors into, one of the reasons is it factors into this perfect square form there. Okay. Now, there's a particular thing that we can note with expressions like this. And depending on the direction that we go, but if I say the square of a sum, so if I'm looking at something like a plus b squared, well, that's going to come out if I, expanded that out. It would, yeah, I'm going to expand it, showing here. So we'll show how it starts off and how it finishes, and all the steps in between. So a plus b, a plus b. Remembering that a plus b squared is just saying a plus b times a plus b. So then we have to multiply all these things out. Question, Josh? No, that wouldn't be the same thing. Yeah. Are you saying, like, as in this could be equal to AA plus BB? No. And this is, I'm going to show why they're not the same thing. Okay. So now this expands into being a times a, which is a squared, that's good. But then I also have, a times a, then I also have an a times b. And there's going to be another one because I've got b times a here, which I'm going to write as ab instead of ba, just because it's alphabetical. And then I've got b times b, so plus b squared. So what do I end up with? I end up with a squared plus 2ab, because there's two of them, one here and one here. And I'll just fix up that b, looks a bit weird. No, that one doesn't look much better. Plus b squared. So the rule then ends up being that if I have an a and a b being added together inside a set of brackets and being squared, then that can simplify out to this. Now, I'm going to say something now, it doesn't really matter. This one here, the sum of a square and the square of a difference, don't really matter. Like, it's fun and useful, but the reality is that you can derive them very simply by expanding that to get that. That's not hard. And then when something's in this form, that's what we've been practicing for a little while now, those quadratic trinomials, factorizing those. It's fine, you just get, half of two numbers that multiply to give the end number and add to give the middle, blah, 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 and you can factorize it that way. Same thing over here, not all that important. There's one, however, that is important because without it, it's very difficult to go in the reverse direction. It's easy to go from expanding, but it's very hard to go to factorizing it. We'll get to that in a sec. Now, if this was the square of a sum, a plus b squared, what would the difference, or square of a difference look like? Sure, a minus b. In fact, that is exactly what it is. So a minus b squared is going to look very similar with one very small difference, but still crucial. So a minus b, a minus b. So what's going to happen here, if I expand this, I'm going to get a squared still. And then what? A times a gives me a squared. A times negative b gives me minus ab, good. And then b times, or negative b times a would be another minus ab. But what about negative b times negative b? Plus b squared. Yeah, very good. Okay, so I end up with a squared minus 2ab plus b squared, and that's a minus b squared. What's the difference between these two things? One's got minus 2b and one's got plus 2b. That's it. Now, the key thing with what Josh said is it's very tempting to go, oh, well, this is just going to be a squared minus b squared when it's something like that. And you can do that if you have a multiplication in there. But when you've got a subtraction or an addition anywhere in these things, then you'd miss out on that part there if you expanded it that way. There is something that does, no, it doesn't do anything like that. But there's something similar to what you're thinking of, and we're going to show what that is next. Well, I'm adding two things in here, and in this one I'm taking them away. So square of a sum, this is the square of a sum, because a plus b is a sum, and this is the square of a difference, because a minus b is a difference. Yep, no, that's okay, no worries. We have a very nice flower over here. Okay. Spot the difference. That's all I was saying, just like what's the difference between these two things. Okay. If anyone hasn't written down that part yet, I would write that down now. So we've written down that part, the sum of a square and the sum of a difference. Now, spot the difference, yeah, there's not a big difference. Now, the key part, why I'm emphasizing these aren't super important, is because if we are given something in this form, now it's not going to look like that with a's and b's, right? It's going to look like x squared plus 2x plus 1, something like that. And we can factorize that. We know that's, well, the two numbers that multiply to give me 1 and add to give me 2 are just 1 and 1. So that would be x plus 1 squared. And if we were given it in the form of x plus 1 squared and asked to expand that, then we can do that as well. We can, follow the whole expansion process with the eyebrows and stuff. That's no big deal. Now, difference of two squares is another matter. Difference of two squares is saying if I have a squared minus b squared and factorize that. Well, that is a bit harder to factorize because I can't follow the normal process that I've followed before, but you have seen now some examples of things where they've done that. If you go into your book, you'll see something along the lines of x squared plus 3x minus 3x, don't look into your book, sorry, plus 9. You might see something oops, sorry, not plus 9, it'll be minus 9, something of that form. Now, if I simplify that, what do I get? X squared minus 9. Okay, now x squared minus 9. Now, what does that look like? I could rewrite that as x squared minus 3 squared, couldn't I? I could if I wanted to. And then it starts to look very similar to this. Okay, so these things look the same, and this is equal to this. Now, if I have this, can I factorize this one? What would that look like? Yeah, essentially I'm asking for two numbers that multiply to give me -9 and add to give me the total of this, which my two numbers are already blatantly given to me here. If I have +3 and -3, what do they add to give me? 0, someone said 0, yeah. +3 minus 3, or +3 plus -3, add to give me 0, which there is no x term in here, yeah. And then they multiply to give me -9, great. So that means then that this thing up here could be written as x plus 3, or minus, I always put the minuses first, but it doesn't matter, and x, plus 3. Okay, that's good to know. So that means that over here, I could write this as a squared plus ab minus ab minus b squared, and that would have to go into these brackets here of a minus b and a plus b. And by that logic, this and this thing are the same, and so this is the case where the factorized version is bigger than the original version. All the other times it goes the other way. So technically when I expand this, I get something smaller, which is, yeah, but they're equal either way. Okay, so did that make sense? A little bit? Just not at all.
If you've made it this far straight,
Yeah.
good job, you're going to get an A.
Okay, thank you.
Thank you, Tom. Gemma 256.
I've already muted it, so, okay. Okay. Yeah, so actually, no, let me format it a little bit better before you write it down. So, oops, don't do that one. No, don't do that either. So I want to delete this part. Okay, and then AB equals A squared minus AB plus AB minus B squared. And that is equal to A minus B, A plus B. And that's our rule. The reason this comes in handy is a lot of the time, like in that little situation before, we get this situation of something squared minus something that can be squared or can be shown as being squared. And then the only way to factorize that is using this rule. That's what makes it easier. Okay, yes, write that down. That's essentially the example there. Is that a question? Shh, shh, shh. Okay, that's fine. Shh. Thanks, guys. Shush. Okay. So that's essentially the rule there. The key part there being that A squared minus B, and I've just written it again, is equal to A minus B, A plus B. This, don't get confused between this. This is not equal to like A squared plus B squared or A plus B squared or A minus B squared. We saw what these two were equal to, and it certainly wasn't that. So let's keep that in mind because, well, some of you are going to make that mistake anyway, but that's okay. Probably most of you. Yeah. Yeah. So there's a difference here. If I have AB in brackets squared like that, that's A times B. And that is equal to A squared B squared. Yeah. But if I put a plus in there, that's not the same anymore. Well, we saw the outcome. Up here, this is exactly why not. Well, it's like saying a tomato is a turnip. They're not the same thing. I can't just say, well, A plus B squared. I'm just gonna delete that from there. Oh, look at that. It's not that anymore. Well, that's not maths. Like, again, we didn't make this up. This is what's discovered. Yeah, we're just following the rules that are there. Okay.
So what if we make the rules?
Well, pity the planet to live on where you make the rules. Okay. I'm gonna put it into practice now. So this first one, based on that rule, and at this point you can either just expand it how you would normally expand it, or you can try implementing that first rule that we looked at, where it was A plus B squared is equal to that. So if this is my A and B, if P is A and B is 4, then what would this look like when it's expanded? P squared, good, plus 2 times P times 4 plus 4 squared. Cool. So that's P squared plus 8P plus 16. Now, if you don't want to, put that rule into practice, you don't have to. You could just write P plus 4, and then do your normal expansion underneath that. Like so. Ready? P plus 4, P plus 4. And now I'm going to expand that. That's equal to P to the 4, that times that. And then P times 4 plus 4P, plus 4P again, plus 16. And all I've done is gone P times P is P squared, P times 4 is 4P, 4 times P is still 4P, and 4 times 4 is 16. And then I can collect like terms here, and I'll end up with exactly the same thing. P squared plus 8P plus 16. Either way, both work, both are completely acceptable. Yep. We're expanding. This is expanding, yeah. But we're going to factorize it as well. But the factorizing, you can just factorize it normally. if the question is in brackets, then yes, you're not going to just be said. I'm not going to give you a thing and just be like, go figure. It'll say expand the following function. Sure. Yeah, it'll say expand the following, or it'll say factorize the following things. Yeah. Yeah. Not, yeah, a little bit. It's pointless in the sense that you can use it if you want to. So we're just giving you more options. Well, if this one way makes more sense, then yeah, use this. But the one that we have to use is that last one, the difference of 2 squares. So this one we have to use that, and that's fine. We'll get used to that. That's no big deal. Okay. Same thing for here, but it's a minus instead. So the shortcut with the rule would be, and I'll do the rule first and then I'll do the expansion second. They're both expanding, but anyway. So the shortcut to this would be d squared minus 2 times d times 3 plus 3 squared. Okay, and that would just be d squared minus 6d plus 9. Again, if we do an expansion, so d minus 3 the old way, well, that's going to look like d squared minus 3d minus 3d plus 9, which would be d squared minus 6d plus 9. Both of them work. Same principles applying to the last one. It's just a bit more complicated because I have 2 elements. Sorry? Oh. I can fix that. How's that? Is that better? It's I either deleted something at some point or just something. I don't know. Interesting one. Okay. Okay, good on the second one? Semi good? Is anyone cold yet?
No, please don't turn the air on.
I'm turning it off. Yeah. It's cold enough. It's not going to heat up. It's cold outside. Okay. Last one on this part. I want to do this. So this is going to be, what's 3m squared going to be? 9m squared. Good. Minus 2 times 3m times 2n plus 4n squared. Yeah, so there's a little bit to keep track of there, but not impossible. Well, that's the rule. So if we look up here at that rule, it was essentially that is equal to 2ab. Because if we do the expansion, we get a squared minus ab plus b squared minus ab is minus 2ab.
And it's about if the world, what the world would look like if a squared minus b squared or something. If a minus b
Squared
is like a squared
minus b squared.
And it's like this perfect world.
Wouldn't be perfect, no. It would be messed up. I'm not sure where that was going. Anyway, let's collect like terms here. Equals Charlie, thanks. Equals 9m squared minus 12mn, yep, plus 4n squared. Now, expanding these is very easy. Factorizing these gets a bit trickier. It's best if we use the PSF method. But we don't have to do that at the moment. Currently, we're just expanding those and just seeing those special rules with expanding. So that's fine. Okay. Now, similarly, on this one, I'm going to show just the normal expanding method as well. So we can do that just by normally expanding. So this is using the rule, and then this is just expanding it without using the rule. So I would write it out as 3m minus 2n, and then 3m, yep, minus 2n. If you want to do it that way, it's totally fine. So first one there, what are you doing? First one there is going to equal 9m squared, as we did just before. Yeah, and then minus 6mn, because I've got 3m times, oops, times negative 2n, yeah, it gives me that one. And then the same thing again, because I go negative 2n times 3n, gives me minus 6mn. And then lastly, plus 4n squared. And that collecting like terms would give me 9m squared, okay. Yeah, plus 4n. Okay, great. So again, the expanding part isn't really the most complicated of it all. But, you know, expanding is very important. We need to know how to expand these things. So if you want to use the rule, you can. That's fine when there's the perfect squares. The difference of the sum, no, the difference of a square. It's the difference of a square. What was it called? The square of a difference. Okay. So if you want to use the square of a difference rule, you can, but you can also just use the same thing that we were doing before with multiplying, you know, expanding the factors there. Okay. Question. Yeah, so the sum of a square and the difference of a square, is that what it was? No, yeah, square of a sum and square of a difference, okay. Yeah, yes, essentially. That only applies to those. The last one, the ones that we're going to do down here are, we're going to expand those and see what those look like, and they're going to be the difference of two squares, which really is, again, I can't emphasize enough how important the difference of two squares is, because we use it all the way through. There's like, it comes up, obviously, when we do a form of factorizing called completing the square, which you'll do next year. And it's used in all of that. And it's just very helpful. Like a lot of the things we can get things to look like a square minus another square, and then we can factorize it that way, and it's really good. So we have to know it. Any questions about that? Okay, last one. Well, it's not last one. Is it last one? No, we've got a few more. Okay. It's great. It's great. Now, this is just expanding. What do we do if we're expanding this? Yep. Yep. Okay. Much like before, I'm going to, that's fine. Yeah, I'm going to use the rule, and then I'm going to, actually, no, I'll do it the other way around. I'll expand it as we normally expand it, and then I'll use the rule and show you how it's a little bit quicker. If I identify here, this is actually, let's just expand. So x squared plus 3x, technically minus 3x, sorry. So I've gone x times x, and then x times negative 3 gives me minus 3x. And then I'm going 3 times x, so plus 3x. And then I'm going positive 3 times negative 3, and the negative times positive is always a. Great, so minus 9. Now, if I collect like terms there, what if I've got negative 3x and I add 3x to it? How many x's am I going to have? 0 x's. So what would I write then? Okay, x squared minus 9. Great. So we can all recognize that. That's fine. Now, I mean, not overly complicated. We can see how that expansion works. If I then want to identify this thing with a's and b's, so let's say a is x and 3 is b. Then when I see it like this, in terms of, well, it's a minus b, a plus b, and what does that equal to? A squared minus b squared, great. So then this factor that I have at the top, or these factors that I have at the top, are going to simplify straight away into what? Okay, let's equate like terms here. I've got x plus 3, let's make it minus 3, and I've got x plus 3 here. And what's that equal to? You can see, yeah, x is a and 3 is b. X is a and 3 is b. Yeah, x squared minus 3 squared. And what's minus 3 squared? Because x squared, minus 9. Now, going in this direction again, not that hard. When we go in the other direction, in terms of starting off with something like this and going back to that, that's where it gets a bit harder. But we can deal with that when we get to it. Okay, so given what we did over here, what would this have to expand into? Done. Yeah, I can write it as 25, but 5 squared is acceptable as well. So yeah, so 25 minus k squared. Yeah. Yeah, unless it's saying it wants it in indice form. Yeah, then you can keep it like that. Yeah, but it wouldn't. It's unlikely. Yeah. Yep. Yep. No worries. Yeah, they're both right. Okay. Is everyone kind of comfortable with this part, or should we do the expansion again? It's okay. Is this all right? This part here. Yeah. Look, it just depends. If like according to this question, no, because they said use the difference of two squares to expand the following. But if they said expand the following and simplify, then yes. If the word simplify is in there, then you can't have any, like it needs to be as simple as possible. If it said expand the following and show in indice form, then you definitely want to leave it there. But sure, that's fine as well. We can do that. So is that 5? Okay. So essentially, we're just associating with our rule here, our A minus B and our A plus B. We're labeling, okay, I'm going to say 5 is A and K is B. And then it's going to be 5 squared minus K squared. It's a very important thing. Okay. So that will make these next few quite simple then. If that's the case, then what's my A in this 3x, right? So A is 3x and B is 2. So then it's going to be brackets 3x squared minus 2 squared. Why did I put brackets around that first one? And the x, yeah. And I want to make sure that as I'm writing it down, I'm not going to forget that that square is applying to the 3 and the x. So correct. So my next line would just be expanding that if you wanted to expand it. 9x squared minus 2. Oops. 4. Minus 4 what? Thought I had 4x. Okay. And that's done. That's fine. It's good to recognize with these things as well. Like you'll start seeing some of these and be like, oh, 9, that's 3 squared, that's good. And 4, that's 2 squared, that's good. So seeing things in their squared form gets really helpful. Okay, so do the same thing here. We've got 4m and 5n. What's my A? Yep, and my B. Okay, good. So we're going to have in brackets 4m squared minus in brackets 5n squared, which would come out to be, yep, minus 25n squared. Yeah, exactly. Okay, cool. And then we're done. I think that's, no, that's okay. I'm just seeing how many more. There's quite a few. Go. All right. Pause it. Oh, okay. So now we've done expanding. Now we're going to do all the same thing in reverse with the factorizing. It is fun stuff. Oops, sorry. What? Woohoo! Yeah. Well, I mean, factorizing is more fun than expanding anyway. I think so.
Can we play like a game which involves this?
Can we play like a game that involves
like a
this?
shootout? And
No.
you say like, what is 4m? Like factorize 4m minus 5.
I'll think about it. I'll see if there's a way to implement that. The reality is, once we've done this, we're finished, and we'll move on to the next. No. That's good though. Okay, can I? Shh. Thanks. Can I move on? Okay. Here we go. So, factorize the following using the perfect square rule. You don't have to use the perfect square rule. Okay. You can factorize it as you would normally factorize it. That being said, I am going to show it up there as using perfect square rule. Okay. Now, perfect square rule is such that a plus b squared is equal to a squared plus 2ab plus b squared. So I want to then show this thing, x squared plus 6x plus 9, in this kind of form. Well, that's going to look like x squared plus 2 times 3 times x plus 3 squared. which, according to my rule, means that it is x plus 3 squared. But if you didn't want to do that, which you're more than welcome not to, you just look at this and say, what two numbers multiply to give me 9 and add to give me 6? And it would be 3. Both of the numbers are 3, and that's why it would be x plus 3, which would be x plus 3 squared. Thanks. Okay. This is an intense one. You okay? No. You can just factorize it normally. It's fine. Yeah. Don't worry. It's like, why? Well. No. Just this is the only one that I want you to make sure that you know how to do. Okay. So because of that, I'm going to fly through these last three here. Okay. These last three, I'm just going to factorize them normally. Two numbers multiplied to give me 25 and add to give me negative 10. So x minus 5 squared. Great, done. What? I just factorized it. You don't have to use those methods, no. You don't have to do that, no. If it's just factorized, you just do that. Yeah, factorizing like you've normally done and expanding like you've normally done. Again, I could. Okay, there's reasons that I don't skip over this because you might be like, oh, what's perfect square? What's that talking about? Well, that's what it's talking about. You don't have to use it. You can if you want. Look, it becomes kind of useful when you get into much more complicated things that don't have numbers and that kind of thing. And then sometimes you can recognize patterns. But, oh, that must be this. Generally, as well, it's just not necessary. The difference of two squares is necessary. And so I am emphasizing that. And we're going to see that. Okay. So this last one here, factorizing this is a bit tricky. I've got 4x squared minus 12x plus 9. Well, I'm going to show that as 2x squared minus, so 12x plus 3 squared. And essentially it's 2x plus 3, yeah. So that one, sorry? Correct, it is minus 3, thank you for that. Squared, yeah. The other way, I wouldn't do it, but I do. The other way to do it with one of those is with the PSF method. But frankly, like this way doesn't really make it much easier anyway. So we'll just leave it at that. That's it for that. Then we've got these ones. And then we're done. I'll do it over here.
So do you do bangs at second period?
What? Oh, yes, I did.
Yeah, it does.
Okay, we all ready? Last section. The most important. Thank you. Can get my megaphone back. Okay. Shh. So, factorize the following using the difference of two squares rule. You do really need, this is the most important part of the whole day. The whole day? Yeah, the whole day. Yeah, okay. So, we want to use our rule to factorize this. And it looks like that couldn't be factorized, but it can. Because what could 4 be represented as something squared? What squared? 2 squared. So x squared minus 2 squared is equal to that. Good, that equals that. And that, remember, if I've got a squared minus b squared, that expands, or factorizes rather, into what? X, and then x plus 2. Yeah, no squares with these ones.
Hey, so.
Yeah, that's because it's factorized. It's not, I haven't simplified, I've factorized. So they eliminate the middle
So
term.
how cool is this?
Sorry, Lachlan. Thank you. I'm gonna stop you there because I want to finish this so that this video can end. Okay. No, that's just this micro. It's just the speaker. I didn't really mute it. I just said that because I don't want you to stop. Okay. Shh. Guys. Sarah. Shh. Okay, we're nearly done. So we figured that one out. What could 25 be written as something squared? Yeah, okay, great. X squared minus 5 squared, which must be x. Excellent. Okay, stepping up a little bit now. Remember, it's not just the last term that needs to be shown as something squared. The first term needs to be shown as something squared as well. Now, in the first two examples we had there, they both were. It was just x squared and x squared. But now I've got 16x squared. And currently that 16 is not being squared, but I need that 16 to be squared. So, correct. So I'm going to put it in brackets and say 4x squared, and 4x in brackets like this squared would expand to give me 16x squared. Great. So I can do that. Minus what? 3 squared. Great. So now I obviously have, in brackets, 4x minus 3 and 4x plus 3. Goodness me, guys. Try and stay with me. Almost done. Does anyone know the beyond 12 times tables?
Yes.
Well done. Good. It is. Yep. Okay. So, now, key thing here, guys, if you get some number, we don't actually have to have square numbers here. And this is not part of this section of the course, but I'll just say that if we had some number here that wasn't a square number, in other words, that if we square root it didn't give us a nice whole number, what would we do? Well, I can still show it as the square root of something squared. Sorry? Surd form, yeah, and I can do that with surd form, and I could use surds in my brackets. Okay, we'll get to that another time. Here we go. Lastly, I want to put all of these as something squared. So 25 square root of that is going to be 5. So 5x squared minus, this happens to be 13 squared. Great. But if I wasn't sure, I could just write the square root of 169 squared. And then in your calculator, you would discover that the square root of 169 is 13. So it's not going to work. But what if it was the square root of 168? Very close to it. Okay, don't write this. Shh. Don't write this, but watch. Shh. Thank you. Don't write this, but watch. If it was like that and I couldn't do anything about it, then I'm still going to take and put in brackets everything that's here that's being squared. So yeah, it would be 5x minus the square root of 168 and 5x plus the square root of 168. And that would be effectively factorized and in surd form. Because I just changed it hypothetically. Like it's not, it's 169, and so it's 5x squared. Okay, back to reality. Guys, I just need like a minute or two more of you not talking to each other and me just being able to finish this. Literally, yeah. Okay. So that and that, square root of 169 is just 13. Put it into brackets, and we've got 5x minus 13 and 5x plus 13. And we are done. Thank you very much. Got it done in under 40 minutes.